Hello students, today I am now going to discuss a very conceptual and very important problem on electrostatics that is important for JE perspective and also CSIR net perspective also. So let's discuss that problem. First of all, it is a thin non-conducting wire that's making a circle that has radius r. Okay, so what we have to find here, it is the center O. Let me write clearly. It is the center O. Okay. Now, what's the thing we have to do? We have to find electric field at the center. Okay. And one thing is given. It has line charge density or linear charge density lambda equals lambda 0 cos theta, where theta is the azimuthal angle. So it's given that a thin non-conducting wire having radius r and who has line charge density lambda equals lambda 0 cos theta. So we have to find electric field at the center, or we have to find electric field at the center of the point O. So let's try to find it. So first of all, we have to take a small element to solve this problem. To always solve this problem, we have to take some small element. How we can take that small element? So now let's discuss. First, draw the circle. Okay. First, I'm drawing the circle. Now we will take small line element dq, that is lambda dl, and linear charge density is lambda equals lambda 0 cos theta. Okay, now here I am considering small element to small element. Due to this portion, it is the radius r. Let me write clearly. Okay. Now, first of all, we will draw that small element due to dq. So, first draw that portion. Now, we have taken small line element dl and dq. For that small line element, dq equals lambda into dl, line charge density into that small line element dl. Okay, and here we have also taken small line element dl and line charge d and small charge element dq. For that also dq equals lambda dl. So now, one thing you have also know that we have also come to know the relation S equals r theta. So here we will do dl equals r d theta. Let me draw it in a clear portion. First, the circle. It is the center. Here both are small element. D theta is the small portion. R is the radius. This is dl. dl equals what? R d theta. As we all know that S equals r theta, so small dl equals r d theta. This small angle is d theta. Okay, these small angles are d theta, and these angles are theta. So due to this dq charge element, we will now consider the electric field by component method. We'll break it into the component method. So let's start discuss about it. So let us consider that component method. So I am drawing very clearly to how to break the electric field component. So first draw a big thin circle. Now as usual, take that element, line element dl. Okay, and here the radius r. This is d theta component, d theta. This is dl equals r d. Let me write clearly. This is dl equals r d theta component, r d theta components. Here it is also d theta, here it is also theta. Now due to it, electric field component is here. Due to this dq element, dq equals what? Dq equals lambda into dl. Lambda is the line charge density we have. Lambda is the line charge density we have. So small charge element dq equals lambda into dl for this small length element. So this for small charge element dq, electric field is here, and due to this small charge element dl, electric field here. So here it is a theta angle. Here it is a theta angle. So here the component will be cos theta component, and this component will be sin theta component. Due to this element here, it is in electric field is directing this. Let me change the pen color, you can understand that. Then due to this component, electric field is directing this side, and electric field component is this side, and due to this line element, electric field is this side, electric field component is also this side, and here in this here the sin theta component is there. Now by free picture I am drawing the component diagram. You can then understand. Let me change the pen color. Okay, this is the dq element. For dq element, it is d theta dq lambda d theta lambda dl, sorry, and here dq let me write the plane. Here this dq lambda d theta, here it is r. So here here due to this dq electric field is there, here electric field is there, and so here due to this dq E1 electric field is there. So along this it is E1 cos theta. Let me change the pen color. So along this, due to this dq element, along this line, it is E1 cos theta, and due to this dq element, here d theta, due to this dq element and along this line, the electric field is let E2. Let me write, electric field is then E2. So E2, and here due to this element, it is E1 and electric field E1 cos theta, and here due to this electric field is E2 and the component along it is E2 cos theta. So total electric field along here, it will be E1 cos theta plus E2 cos theta. So total electric field along here, E1 cos theta plus E2 cos theta, and along this line, this sin theta component, due to this E1 sin theta and due to this E2 sin theta along this, so their sin theta components are cancelling each other. So only electric field will be E1 cos theta plus E2 cos theta. Hope I will draw another again. I will draw again to make it more clear to you. Now by circle, So again I am recapitulating that portion. Due to this element dq, so only electric field will be along this side, and that will be u1 cos theta plus e2 cos theta, because sin theta components are opposite to each other. Here and here sin theta components are opposite to each other and cancelling each other. So now we will calculate the electric field now. So now what we can write, dq equals lambda dl, okay, and lambda 0 cos theta we have taken into rd theta, okay. And what we can write another thing is that, and the electric field will be what? Electric field, now if both due to line element the same, if dE1 equals dE2, so electric field due to that line element at the center will be what? 2, only cos theta component was there, na? 2 dE1 cos theta. So 2 dE1 cos theta. Now if we integrate it, we will get the value of electric field. So let's now integrate it. So electric field equals 2 dE1 cos theta, and dE1 equals what? dq by 4 pi epsilon naught r square cos theta. Okay, it's good. And again we are writing explicitly dE equals 2 into lambda 0 cos theta into rd theta 4 pi epsilon naught r square into, again dl cos theta component was there, into cos theta. We have broken into dq equals lambda dl, and lambda equals lambda 0 cos theta into d theta. Okay, now if we integrate it, so first of all r and r square will be cancelling, and here it will be r. So if we now integrate it, E equals 2 into lambda 0 cos theta into cos theta, that is cos square theta d theta, and 4 pi epsilon naught r. Now 2 cos square theta can be written as 1 plus, and the limit will be what? Theta equals 0 to pi. Now if you break the 2 cos square theta as 1 plus cos 2 theta and putting it here, then after integrating it you will get the value E equals 2 into cos square theta, you have broken it. Let me erase it. E equals 2 cos square theta, what you have written? Cos 1 plus cos 2 theta. So lambda 0 by 4 pi epsilon naught r integration 0 to pi 1 plus cos 2 theta d theta. Yeah, this is the integration. This is the electric field. So after integrating it, you will get, so after integrating it, you will get electric field at the center as E equals lambda by 4 pi epsilon naught r. So this is the required electric field at the center. So thank you.